Okay, let's take a look at section 2.3 and a little bit of 2.4. And these sections are on linear functions or writing the equations of a line. This is a very, very important topic. You've got to get really good at writing the equations of lines. You're going to use this again in this course. If you take statistics, you're going to use that when you do regression lines. If you do go on to pre-calculus, maybe for your major or whatever down the road, lines are going to come up over and over again. So really pay special attention, take good notes, and email me if you have questions about any of this, because it's a really important topic. So first I want to remind you of what we mean by slopes. When we talk about a line and we talk about the equation of a line, looking at the graph of a line, what does the slope look like and what are we talking about? So slope really means how slanted is the line. You can kind of think of it as the slantiness of the line. Is it a really steep slope with a high slope, or is it a little less steep? You might have thought of it as rise over run in the past. It's the change in y over the change in x. So we've got a line in this picture that's rising from left to right. Remember, we talked about increasing and decreasing. So this would have a positive slope because it's an increasing line. And make sure you know the formula for the slope of a line, y2 minus y1 over x2 minus x1. That's how you get the slope if you're given 2 points, and we're going to use that quite a bit in this section. Line slope can have 3 possibilities, so it can look like, actually 4 possibilities. It can look like the one we just looked at, where it rises or is increasing from left to right. That would be a positive slope. If it's decreasing or falling from left to right, we would say it has a negative slope. It can be constant as we go from left to right. So remember we talked about functions that are constant, and if it's constant, then it would be a horizontal line, and the slope would be 0. And the last possibility is that it could be a vertical line. And so if it's a vertical line, we say that the slope is undefined. Make sure you keep these two straight. I remember as a student thinking, well, what's the difference? Aren't they the same thing? They're really not. If a line is horizontal, the slope is going to be 0. If the line is vertical, we'd say it has no slope or is undefined. Writing the equation of a line, there's 3 versions or 3 formats for a linear equation, so make sure you're familiar with all of these. The first one I think is probably the easiest to use, so this is usually the one I start with, is point slope form of a line, and that would be y minus y1 equals m times x minus x1. M, of course, is always going to be slope in these, and then x1 and y1 refer to a point on the line. It can be any point on the line. The next one, which is probably the one you're most familiar with, a lot of times this is the one that high school teachers emphasize, and that's slope-intercept form of a line. Y equals mx plus b. Remember that m is the slope and b is the y-intercept, so specifically it's the y-intercept. And then the last one is standard form. So with standard form, everything has to be on one side. Sometimes some textbooks will put the c or the constant on the other side, and that's okay. It's still standard form, but the x and the y terms have to be on the same side. And there's one more caveat, is that the a, the term in front of the x, the coefficient on the x, has to be positive, and there cannot be any fractions. So if you have any fractions, you have to get rid of those. So let's do some examples. So this question says, write the equation in all 3 forms. They want us to practice all 3 of those forms of the line passing through the point -1, 3, and has a slope of 4. So this time they've given us the slope and they've given us a point on the line. I recommend, and if you've got other ways you'd like to do this, that's up to you, but I recommend always starting with point slope form, because you can use any point on the line. It doesn't have to be the y-intercept. Any point will do. So in this example, they gave us the slope, which is m, and they gave us the point -1, 3. So I'm going to substitute that information into my equation. So notice where everything is. The slope replaced with a 4, m is 4. x1 is the x-coordinate, so that's -1. y1 is the y-coordinate, so that's 3. And then we've got the x and the y variable in the equation. Simplify that, just take care of that negative, and you've got the point slope form for the equation of the given line. Now they wanted all 3 forms, so let's convert this next into slope-intercept form. So slope-intercept, the y has to be by itself. So the way we're going to do that is we're going to start by distributing the 4. And then adding 3 to the other side. So we get y equals 4x plus 7. 4 is still the slope, and if I asked for the y-intercept, you tell me it would be 7. And then last, they wanted standard form. They want all three, so we'll do standard form. So for standard form, the x and the y have to be on the same side. We could subtract the 4x and the 7 to the left side, but we could also just subtract the y to the right side, and that would be in standard form. Notice there's no fractions, and notice the coefficient on the x is a positive 4, which is what we need for standard form. Okay, let's take a look at this question. It says, find the equations, again in all three forms, of the line passing through these 2 points. So hopefully the first thing you notice here is they did not give us the slope this time. Like in the last example, they said the slope was 4. This time they did not do that. So the first thing you should think of is I have to get the slope. If they don't give me the slope, I have to know what the slope is. You've got to know that for every line. So that should be your first thought, is how to figure out the slope. So since they gave us 2 points, I'm going to use the formula that we had at the very beginning of the PowerPoint, the y2 minus y1 over x2 minus x1. Does not matter which one you assign y2, and y1 makes no difference. I use 6 as y2. That means negative 3 would be y1. So y2 minus y1 in the numerator. The denominator then, you have to be consistent, so that means x2 has to be the negative 2, and 4 would have to be x1, so we have negative 2 minus 4 in the denominator. Make sure you put y's on top, not the x's, and make sure you're consistent about lining those up. So if we simplify that, we get a slope of negative 3/2. Now let's go back to our equation that they wanted. So we need to write the equation in point slope form to start off. You could pick either point, it makes no difference. I chose the second one, no particular reason. So I've got y minus 6 equals negative 3/2 times x minus a negative 2, which is x plus 2. Okay, so next they wanted the equation in slope-intercept form. So make sure you see what I'm doing here. I take the point slope form that I had. I'm distributing the negative 3/2 first. So that gives me negative 3/2 x minus 3 because the 2's cancel. And then I'm going to add the 6 to the other side. So that gives me slope-intercept form of y equals negative 3/2 x plus 3. Last but not least, they want the standard form. So to get standard form, I need to get the x's and y's on one side. So I went ahead and I moved the 3/2 x to the left side because that makes it a positive. Remember, the x term has to be positive. Then I went ahead and moved the 3 with it. Now remember, you can't have any fractions. So I'm going to clear the fractions by multiplying everything up there by what would get rid of those fractions. Think back to chapter 1 when we did clearing the fractions. If I multiply everything by 2, make sure you do it on both sides. The 2's cancel in that first term, so that leaves me with 3x. 2 times y is 2y, and 2 times 6 gives me, or 2 times 3 gives me 6. Okay, next thing we want to be good at is graphing the equation of a line. So this is y equals 2/3 x plus 2. So what is the slope here, and what is the y-intercept? Y-intercept is 2. Slope is 2/3. So remember, to graph these, you start at the y-intercept. So the y-intercept is 2. So I started at 2 on the y-axis. And then since the slope is positive, I go up. I always run to the right, but if the slope is positive, I go up. So from the y-intercept, I went up 2 and right 1, 2, 3, and put my second point. Had the slope been negative, I would have gone down and to the right. Let's try this one. So we've got 6x minus 3y equals 12. Notice this is in standard form, not slope-intercept form. We could rearrange this and put it in slope-intercept form, get the y by itself, but I want you to try a different method here, and that is to find the x and y intercepts. If we have 2 points, it's all we need are 2 points to graph a line. So if I can get the x-intercept and the y-intercept, I'm good to go here. So remember, to get the x-intercept for a function, you replace y with a 0, and then solve for x. We get x equals 2, so the x-intercept is 2. To find the y-intercept, we replace x with a 0. Whichever intercept you're looking for, you replace the opposite variable with 0. So I'm going to replace x with 0, and I get this expression. Solve for y, and I get negative 4. Now I'm going to go to my graph, and on the x-axis I'm going to put a point at 2, and on the y-axis I'm going to put a point at -4. There it is. So x-intercept is at 2, y-intercept is -4, and then you're just going to connect them. Horizontal lines, remember the slope of a horizontal line is 0, but if you're asked to write the equation or recognize the equation, horizontal lines are always in the form y equals a number. Vertical lines are always in the form x equals a number. So here's a quick simple example. If they asked us to graph the line x equals 5, that would be a vertical line that cuts the x-axis. I remember these because x equals cuts the x-axis. So that's a vertical line. You can kind of see in this picture that blue line there, that's x equals 5. And then the line y equals -4, that's a horizontal line. I remember because it cuts the y-axis. That would be the line in red, y equals -4. Okay, let's talk about parallel lines for a second. So if you'll recall that lines that are parallel never intersect. And so the big characteristic with lines that are parallel is that their slopes are the same. You've got to remember that rule. Parallel lines, the slopes are the same. So this question says, write an equation of the line passing through the point -3, 2, and parallel to the line whose equation is y equals 2x plus 1. So as always, when you write the equation of the line, your first thought should be, what's my slope? So I need to know the slope. Since I'm looking for a new line that is parallel to the given line, I need to know the slope of the given line. And hopefully you see the way this is written. It's in slope-intercept form, so the m is 2. So my slope is going to be 2. And so I've got a point, -3, 2, and I've got a slope of 2. So I'm going to put it all together in point-slope form. So we've got y minus 2, that's the y-coordinate, equals 2, that was the slope because they had to be the same, times x minus -3 or x plus 3. So here's a picture. The line, it looks like in purple, is the original line. The line in blue is my new line, so you can see that they are parallel. And by the way, you notice I left this line in point slope form. They did not tell me it had to be in a particular form, so I'm going to leave it in point slope form. That's a valid answer. If they don't specify it needs to be in slope intercept form, you don't have to change it to that. Okay, perpendicular lines. So remember that lines that are perpendicular intersect at a right angle. Algebraically, the way you know they're perpendicular is they have opposite reciprocals. Their slopes have opposite reciprocals. So what do I mean by that? Reciprocal, you flip the fraction. Opposite, you change the sign. So for example, if I had a line with a slope of 2/3, a perpendicular line, you flip it, would be 3/2 and change the sign, make it negative. If I had a line with a slope of -2, flip it, would make it positive 1/2. Or flip it, get 1/2, opposite sign would be positive. All right, so let's try this example. Find the equation of the line that is perpendicular to 2x plus 4y minus 4 equals 0 and passes through the point -1, 0. So again, first thought should be I need to know the slope of my line. So in order to figure that out, I need to know the slope of the given line. Well, you notice this time they gave you the equation in standard form, so we need to do some rearranging here with this line to get the slope. So to do that, remember you need to get y by itself, so I'm going to subtract the 2x and add the 4 to the other side. I'm going to divide everything by 4, so everything gets divided by 4. -2 divided by 4, 4 divided by 4 gives me 1. So my slope of the given line is -1/2. If I reduce it, what's the slope of my new line going to be if it needs to be perpendicular? Well, I need to flip it and change the sign. So the slope is going to be +2. So now I know the slope is going to be 2, and I know it needs to contain the point -1, 0. So I'm going to write it again in point slope form. Y minus 0 equals 2 times the x minus -1. I went ahead and cleaned this one up a little. That wasn't necessary. Y equals 2x plus 2 would be the equation in slope-intercept form.